the sum of the derivatives times the difference between the w's. Minus 2 times L W0. The opposite sign for the other one. Divided by the third power of the difference between. Which is the same thing I had here. Difference times the sum minus 2 times that divided by. Yeah. Well, that really it looks correct to me. Well, clearly it isn't. It isn't going through P1. It doesn't even have even close the derivative here. Nor there, wherever the point belongs to. It's completely wrong. The derivative is now correct. Bah. Yeah. I don't know. That's interesting. If I move the point, no, it's not true. This looks like a correct fit. But yeah. Coincidence, I suppose. What is wrong? I checked the math twice, so I guess my program is wrong. Well, I can just drag my points around. What kind of comment is this? It's just a direction. Should be correct. The direction is yeah, well, maybe negative that, but then no, then even then it would still have to go through P1. That is correct, of course. It's point Q minus the center of the circle. Then W0 is per definition the x-coordinate of the point P0. And the y-coordinate is LW0, and the derivative is given by the y divided by the x-coordinate of the unit vector D0. And the same here. But then P1 and D1. Hello, box. Only nominal cubic has 4 coordinates. Coefficients, I mean. Delta W is W0 minus W1, and then that to the third power. God knows, maybe it makes a difference. D is W, wait a minute, this one, W0 minus W1 times derivatives added minus 2 times the difference between the L values. Divided by third power of that, so that's the same formula. And then C equals the difference between the derivatives divided by 2 times delta W. Minus 3 divided by 2 times... Oh, that is a big. That must be the sum, not the delta. Aha! There is hope. Times D, yep. Well, let's check the last one as well, although now might work right, hopefully. Andrew, the ultimate goal is to make me happy. Is that less than 10 words? It's in the title. I'm trying to find an optimized gradient descent algorithm. And then, of course, finish machine learning, write a better ChatGPT and take over the world. But that's more than 10 words. So this is the formula for B. W0 times the derivative minus W1 times derivative divided by delta, and then plus 3 times... So that was good. Yeah, well, we found a bug. C is different. Now it must work. Everything will just work. Sure of it. Yes. Look at that. So now I have a cubic that is goes through P0 and P1 and has the correct derivative. The derivative that I have specified here. Oh, very good. No, it's not. Look at the link in the description. Oh no, that's just a question. I think I can post my answer here because it's kind of finished, right? I used this and it worked. So I wouldn't call this trial and error, is it? Just hard work. Mathematical. Right, so the idea in now is that if we have this point here, look at this derivative, and we have this point here with whatever derivative, I mean it's higher than P0, so no matter what I do, there is a minimum between P0 and P1. Always a minimum. Well, this may be dubious, but it's definitely, no, this here, this minimum is here still, yep. More realistically, here's a minimum, and if you make it point down, then there is still a minimum, of course. And then if I move this thing down, 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 then when exactly does that minimum disappear? Well, here it disappears. Here it comes back. Yeah, I can imagine that the existence of this thing here is purely the sign of the discriminant that I had, aka this value. That must be larger than 0, aka if c squared is larger than 3d, then we have 0. But let's just draw a vertical line through the minimum at the moment, so which will fail, of course, if this thing is less than 0. C squared minus 3d. Let's draw this thing anyway. Double. How shall we call it a D? The D of discriminant. On dot. I wouldn't know, man. What do those terms mean? I seldom do anything with user interfaces or graphics for that matter. Even though I wrote this, so it's kind of one of the first things basically I wrote. this graphical window where I can draw my mathematical formulas. Usually I'm coding just, you know, stuff in the background. I think most of my work has been related to networking stuff. Yeah, or math, you know, it's just a program crunches and gives you a nice output. So I'm usually not dealing with input. Okay, let me think here. Of course, you want to do like if d is greater or equal 0, then we can do something. And then do it. But I want to draw my line here. And that means that whatever this thing is returning must exist and keep existing, because the line disappears if I destroy the returned object. So it should create an object here. I think it's a plot line, right? Plot zero line, yeah. That was the name that I used. And then I have to use not create line, but add line. And I can just pass the thing here, I think. Let's see if that makes sense with add line. That's a line piece, another line piece. And what the F? Layer, line style, line extend. This doesn't even have a... What? I think I need this one. This one talks about line. So why did I not see that? No, whatever. This is the one. So it's a layer, line style, and then plot line. I guess I have to construct a line or something. God, how this works. Direction. Damn it, I forgot how it works. Why? No, that seems to work. So we now have a vertical line here. So now to figure out where the 0 is. The 0 is, that is my W plus here, right? So that would be this. 2 times the square root of my discriminant. Nope, not at all. Why is it drawing a line to begin with? W should be negative here. At least, you know, we don't have a minimum. What the hell? This has nothing to do with my... Nothing. No, that's still wrong then. I do have my cubic, and the derivative is b plus 2cw plus 3dw squared. Yes. Set that equal to 0. Then the roots are minus 2c plus or minus the square root of 2c squared minus 4 times 1 times 3d. Divide by 4. Divide by 2 here. 2 times 3d looks correct to me. Bullshit. Sorry. Is not equal. This is a colon or something. Corresponds with. I filled in the plus. I should put a Q in around it, I suppose. Something like that. Let's edit this. This gives, where is it? Yeah. So the minus corresponds to putting a minus here, and then if you fill that in the second derivative, we get 2c plus 6d times, and then the w, which is this with a minus sign, which, and then you can drop the d cancels, and this becomes a 2, so the c cancels, so you end up with minus 2 times that, which is less than 0. And if the second derivative is less than 0, you have a maximum. Yep, therefore the cubic has at most 1 minimum in W plus. But I still have to use the correct formula, not this. That's bullshit. You have to use this one, but then with a plus. So it's minus c plus that square root divided by 3d. Oh, it's unbelievable, but yes, it's minus c plus that square root, all divided by 3 times d. And that will be the minimum. And we still have a minimum. What the hell is this doing here? It's absolutely not working. Just what the hell is wrong here? Yeah, again, Q is that, derivative is. Yes. The derivative is 0 when we say that it is 0. And then we can solve that, and then W equals... I checked this again already. This is just correct. Okay, let me do it again on paper. I'm an idiot. I forgot. I was looking like 2C is the okay. I'm just an idiot. I forgot the B here. That must be 3dB. Okay, let me work it out. So this is obviously 4 times 3D times B divided by 2 times 3D. And then we can remove this, and this, and this, and this. Yeah. Okay, there must be 3dB. And then here as well, and here as well, and here as well, and here as well, and everywhere. What is the first formula? 4. Formula 4, take 5, take 4. B. AC, let's put it there first. BD. Okay. That should be it. That's better. No vertical line. And then I do this, and there it is. The vertical line is the minimum. Ish. Okay, so it is possible that we do have a minimum, but not in between P0 and P1. Namely, I just had one. Yeah, there, for example. Is it possible that the minimum is on the other side? Because we had it in between and on the left of P1. Can I create a minimum on this side? Yes, of course I can. Of course I can. Or not. Yeah, well, maybe not, actually. A minimum on that side. Well, oh yeah, there it is. Dang. Okay, so the minimum can be anywhere. We really have to check if... well, that would be weird though, but well, in general, I guess I have to check if it is really in between these two. I mean, it is definitely weird because I'm looking for a minimum on the right side of P0 in this case. Well, I'm talking about a minimum. I think in this case I would be looking for a maximum. I definitely would, wouldn't I? I'm looking on this. Well, no, I think about it. Yeah. I'm looking on that side of P0, that where the vertex is of the parabola that fits this curve in P0. And that would be like a parabola like this. So I would be looking on the other side. And then I wouldn't even care about P1 at all. Ever. So I don't think this will happen. Yeah, maybe I should draw the problem as well. Let me think. I'm not sure though. I'm definitely not sure. Let's just check if it is in between these two. Yup, that works. Hey. Of course, the derivative 0. Keeps being cool. Play with this. Right, okay, so I think this answer is correct now. And the code as well. So now I would have to go back to the previous program and then use this. quite a lot of calculations, but well. Gradient descent. So I have an ignore lambda here. Which tells me, which should return true if the sample must be ignored. And that it should be ignored if there is not a minimum in between those 2 points. Which 2 points? I think W is the old value. So we want to jump from W to the vertex, X coordinate of the vertex. And then this lambda is called with samples that it must decide on whether or not to ignore it. Which means that W is the W0. I think you can do something like W0 is W. I need all of these. I think I'll have to get them from current. Maybe this compiles. Right, but oh wait, that's still a maximum. Well, this is only working for a minimum. Do we need to know really if we are looking for a minimum or a maximum? Yeah, make it a double maybe, I don't know. Is that faster? Make it, make it a Boolean, I don't know. Damn it, it must be here. There's maximum here. It's just the 2 approximation itself. I'll make it a maximum. Jeez. Instant failure. Let's zoom in on this. So from 10 or something. That didn't work. Oh, that, never mind me. Claimed by sample a 12. My parabola has a maximum. Therefore, we should be looking for a maximum. We draw some 30-degree polynomial through these 2 points that are almost on top of each other, and then I'm very sure there is not a minimum in between. So I did it return true. Possible. a little bit more than 12. That's correct. And this should be negative. Oh. No, of course not. I thought, this is the vertical thingy. So that is totally, yeah, correct. No, the derivative should be negative. Yes, okay, and then W1 is probably the thing at 12. Which is a little bit higher. Really tiny little bit, but it's not. Really tiny little bit. And it should be less steep as well, of course. You're closer to the vertex. So this is a tiny absolute, a little bit less. Quite a lot even. Still negative, but yeah, the absolute value is less. Everything is expected. Then this becomes negative. Yeah, because that should not matter. Oh, it's not negative. Actually, this is a positive this way. Okay, well, so much better. Does that look like a third power of that? Suppose it does. Yeah, I can't check this, or I would have to draw it. It's not go that way yet, so I just assume that it worked because I tested it. This gives me a positive value. Okay, what does that mean? That means that whatever we fit it to does have a minimum and a maximum. And that seems very likely because it looks a lot like a parabola. Yeah. And then by some super coincidence, this is going to be between W0 and W1. No, never, never, ever, ever. I think the logic after this fails. Is absolutely not true. In fact, it's perfectly matching my parabola. I mean, parabola is that it's what is it, a sine or something, but looks like a parabola here. 11.4, yeah. That's where the maximum is. Because we are looking for a maximum. And that's where the maximum is. And that is totally not in between W0 and W1. Oh, this fails because W0 is not less than W1. Ha ha ha. That's what. Okay. This should. The whole idea was that this should return false. But on the other hand, I think it should still return false, shouldn't it? Well, this is true. But this is false. Definitely should be false. Yep. So we do not jump into the f, and therefore we're going to return false. As in, do not ignore it. Oh! Yeah, I'm brilliant. But there we found the bug. If there is not a minimum, then it should be ignored. Okay, so this must be true. And this must be false. Yep, okay. What is a good way to test if something is in between two variables if you don't know which one is larger? I just did a billion calculations and now I'm whining about a possible branch. I'm an idiot. Let's just add a branch, right? But still, not a smart way to do this. Nope. I can't think of any way to do it, so I'm gonna do it the slow way. Deliberately the slowest way. No, it seems to work. It ignored it. So let's go back to go. What the hell? What the hell? A clumping happened. Yeah, here we see the approximation now, a parabola with the vertex at 0.3. So that is definitely a parabola, this one here, where it says it's 0 somewhere here. But then it returned minus 55 instead of 0.3. Because we got clamped by minus 52.2, which is which one? I'm gonna guess 44. So it did jump over 47, got clamped on 44, and then made up that it had to jump right to the minimum that we were looking for. What? Hello, CWK, no, CDKW2. Minimum reached. Holy fast. This is working much better than I had expected. No. There we are. Suppose it's correct. So maybe I should zoom in a little bit here. So let's just show minus 60 to minus 50. Or even less than that. Let's say, I don't know, minus 54. I don't want to see all of this. I think this is 55, isn't it? Minus 60 to, I don't know, minus 54.5. So we are trying to find this minimum where this part is a parabola. Looks like a straight line, but it's a parabola with the vertex way, well, almost, well, 0.3. So yeah, once you have 2 points here, normally it would jump to like way far to the right. But if we already come from the right, so I have to type a lot of spaces now in order to get here. There we go, that's the first one, and then that's the second one. And then it thinks that it is this parabola here. But it doesn't jump to that vertex, it gets clamped on the last sample that we measured up there, which then returns, yeah, that's almost by coincidence, I think, almost exactly in the vertex, sorry, in the minimum. Would it be more fun if, say, we ended up here and then see what it would be doing then? So already have a reasonable parabola fit here. That is very deviating from this one. What is rejected here? That's a jump. Minus 116. Dude, why? So we're here and we're jumping extremely far to the left. A bit too far if you ask me. But yeah. It kind of works. And that's the minimum that it found. It's pretty good. Maybe I should still draw a problem. I'm going to delete this. Have it in LaTeX. Yeah, I have to change this back. Before I do that, I could play with this. If we put this at 0.6, now that doesn't jump exactly to the minimum. And then you can see how that works. It's close to reasonable jump. Too many changes. Yeah, but before I change this, I wanted to do the reasonable jump. Hey, CDKW, yeah. I won't make it too long, I think. Let me see. Yeah, let's make this 0.6. Just for fun. Okay, that's shocking. Missed it. Did you miss it? Didn't even jump close to the... but okay. How the hell can it say that it found a global minimum here? We're still moving towards a better minimum. Yeah, make no sense. Or does it? Oh, right. Oh, right. Oh, 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 oh. Okay, that's interesting. So this is a problem of the vertex far on the right, but then we go to a sign here, which the sign itself would go down, 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 down. And the sign gets more and more influence, and it has already influence here. So point 50 is actually a little bit lower because it starts moving towards the sign, which is somewhere down here at that point. So the curvature is now like this. And we get a parabola fit that has its vertex far on the left, because 50 is now taken into account. Man, this is wrong. This is wrong. I'm not looking for a maximum. Why? That's, I mean, really, it should have been ignored. I'm looking for a minimum. I'm pretty sure of that, right? I mean, we had a maximum here, and now we're looking for a minimum. And then we fit the parabola here that has a vertex on the left side. Well, ignore it. Just go in the same direction as we were going. Well, that's what I want. I want to go that way. Actually, I am going that way, but we did overshoot the minimum. Oh my god. I could already have known that there is a minimum between 47 and whatever's up there. 44, I think. Should never have gone to 48. Oh man, this opened a can of worms. Oh my god, yeah. Ugh. It's kind of like a binary search. You know you're on the left side, or you know you're on the right side of that minimum, and then you have to bounce back and forward until you find it. I'm gonna have to give this a lot of thought before I can continue. But what is definitely wrong is that it did not ignore the vertex of this problem fit. It jumped there, right? No, it's a continue in the same direction thing. Okay, it did ignore that fact that it is a vertex. So it's like, okay, we have a vertex, but it's a maximum, and I'm looking for a minimum. Therefore, continue in the same direction. We are going in that direction because, well, the minimum is here. I was there. We jumped over it. I realized that here. So I go back. But then suddenly we don't see a minimum anymore because now the parabola looks like this. And at that moment it says, okay, let's go in the same direction. And that direction is that direction. So then it jumps to the left. I could argue same direction here we should go from 49 to 50 and then continue in the same direction. But yeah, well, actually, no. It's more like if you fit a third-degree polynomial through 49 and 50, there's no minimum. Now, if you fit a third-degree polynomial between 50 and 44, then there is. Therefore, we should go in the direction of 44 because we're looking for a minimum. This is a new algorithm that I haven't included at all yet. Okay. And I want to go I want to see what happens if I make it a little bit small. Anyways, because that's what I wanted to see. No. Nothing interesting. Mm-hmm. Yeah. Let's start at minus 51. This is the interesting part at the moment. No extreme has been found at all. Yeah, I beat my algorithm. Interesting stuff, though. Well, but thank you for the upvote, whoever did it. Let's play a game of chess because it's definitely that time. I've been losing so much. In a second, I'm gonna drop below 1900. I need a new chess lesson for. What am I doing here with my bishop? For the Thursday, right? Still a couple of days, but might as well have a look at it yet. Look at it already. You can play that game. Yeah. Thou shalt not castle. Let's give a check. And then again threaten mate, and then the queen has to go there. And then I don't really have much anymore, right? Actually, if we go here, that would be, and he goes there, and he takes my queen, I can take back and win the quality. So he can't take my queen. What do I want to do with my bishop in the meantime? Maybe I should just castle after this move, I mean. No, this has to be moved. I have to move it. Maybe take here. Queen takes. Doesn't really matter, I suppose. Damn. Yeah, otherwise he attacks my knight. Is that a problem? Let's take it here. Could probably still do it with this knight though. And then I guess I should castle. I would like to have pushing this pawn a problem. Kind of is. I'm gonna go this way. Maybe I should just push my own pawn. Oh, like that. Okay, I'll just take this one for free. I think that's possible. Yeah. I think a knight takes is possible, isn't it? No, I take the rook over check. It's my move. Oh, the king went to the side. So I can just fork it now. Not really the optimal place to go, I suppose. Quite why not move, right? Can you prevent it? Can put this here. Definitely can put this there. Just push it. Get rid of my weak pawn. I'm definitely sure that he's going to take it, and then I'll take back with the knight. He's not taking it. I'm glad I didn't pre-move that. Interesting move. I think I just push. Okay. Yeah, bishop g4, I guess. Bad bishop. Exchange it. He does not want to do it. Maybe I should not have done that. Just maybe. Could have done this, taking both. I think it clearly shows that this guy has 1800 something. What the hell, dude? It's almost the same as my rating, but I should be down here. Damn it. (2001). Is that a chance to? Always those annoying moves. 2000 players. I think that is a certain type of opening. No, that then the bishop should have exchanged this one. Guess I could just castle and then exchange my bishop. Or not. Bishop there is a problem. Shit. He doesn't see it or what? Hmm. I'm having a bad bishop. Actually. That was a good move. What to do? Oh shit. Yeah, that's pretty much lost then. Very lost. Yeah, look down. Oh boy. So bad, so bad, so bad, so bad. Yeah, well. I'm out of options. I'll just have to eat dinner, I'm afraid. So I guess that's what I'm going to do. I'll see you guys later.